Okay, last time we talked about radian measures, all nice, fine, dandy. There are some angles, either in radians or degrees, that you will have to memorize the trig ratios, sine, cosine, and tangent for. Why? Because you have a paper one which has no calculator. If they ask you a question in there, it will have to be about some of these angles. Which angles are we talking about? Well, the 30 degrees multiples, the 45-degree multiples, the 60 degrees multiples. Yes, I know it's like a multiple of 30 degrees, but ignore that little problem. And 90 degrees multiples. They all have kind of their own characteristics. Now, you can try to memorize. There's like all kinds of ways to memorize these ratios for sine, cosine, and tangent. I will show you one way because it's the least amount of memorization I need to do, okay? And it's the two boxes that I've got above that. This one, the first box with the C-A-S-T, I call it cast because ast doesn't work. So cast works nicely. So memorize that and then memorize these two triangles, okay? So I'll kind of walk you through that real quick. If you aren't good at memorizing that off the top of your head, at the beginning of an exam or a test or something like that, if you just kind of scratch down those two triangles, you can kind of look at them while you're working things out, okay? So, what do I mean by that? Well, those two triangles, pretty easy to come up with. So first of all, if you have a 45-degree triangle, it's actually really easy. That one, the 45-degree one, there's no reason where you can't figure this out because 45 degrees means this is 45 degrees, which means the two sides here and here are the same length. So let's make it an arbitrary 1, 1. You can figure out with a squared plus b squared equals c squared that this is equal to the square root of 2, and there you have it. That's your first triangle. So for this one, if I ask you what's the sine of 45 degrees, okay, that's going to be opposite over hypotenuse, so 1 over square root 2, and you can rewrite it like this if you want. That's optional. Cosine of 45 degrees would be adjacent over hypotenuse, and it turns out to be the same thing. Again, I can what's called rationalize the denominator by multiplying top and bottom by square root of 2. Not necessary, but nice. And then last but not least, the tangent of 45 degrees is opposite over adjacent. So it'll be equal to 1. You have to know that. Notice I didn't use a calculator for that, so I know these ratios, okay? Now, what about the other one? Well, I can give you a longer story here, but yeah, sure, why not? Let's give it to you. If I do a 60, 60, 60 triangle, okay, in fact, I'll erase that top one because I'll be writing on top of it, right? I can kind of arbitrarily give all three of those sides the same length, and I will arbitrarily give them all a length of 2. Why? Because I'm about to split this one, this last side. I'm going to split it into 2 like this, cut it straight down like this. So that means that this becomes 1 and 1, okay? Now I don't need both triangles, but I think it's pretty easy to realize that this now makes this 30 degrees and the other side here 30 degrees. So now all of a sudden I have that little triangle that I was working with that I wanted, the 30, 60, 90 triangle. Now this one has these sides, I've already told you. So what side is that third one? Well, it'll be 1 squared plus I don't know squared equals 2 squared. Work that out, and it's square root of 3. So I have those 2 triangles that I boxed originally on top. Learn them, love them, tattoo them on your arm if you have to. If you know these things, you're all set, okay? So what are they for the sine? So if I start asking you sine of 30 degrees, what's that going to be? I just look at that triangle. Sine of 30 degrees is opposite over hypotenuse, so 1 over 2. The cosine of 30 degrees will be adjacent over hypotenuse. The tangent of 30 degrees is equal to opposite over adjacent. Ta-da! The sine of 60 degrees will be what? Opposite over hypotenuse. In this case, square root 3 over 2. the cosine of 60 degrees will be adjacent over hypotenuse. And then the tangent of 60 degrees will be opposite over adjacent. Ta-da. See, I can just do them. What I'm doing is I didn't memorize these really, although I've done them quite a bit. I've just been looking at my triangle. Tragically, this is not your formula booklet. Okay? Now, that's great for 30, 60, and 45. But I have to be able to deal with 90 degrees and beyond, because if I go beyond, so if I look at more of like a unit circle, 30 degrees is fine, 60 degrees, 45 degrees, that all makes sense because I can draw these little triangles. But if I start working with angles that are bigger than that, so again, let's draw that little circle thing. If I have an angle like this of 120 degrees, right? What's that going to be? Well, maybe it's time to give up on the idea that it's opposite over adjacent and all those things. It's like, and think strictly in triangle terms. What you can think of it is, it is this triangle, but for this, like the 120 degrees is not in this triangle. So it seems kind of weird, but it doesn't matter. What we talk about more is that these are the coordinates, and this is the y coordinate, this is the x coordinate, and this is the radius, which we'll typically keep at a unit circle, so 1. So we're interested in the coordinates of this thing. And it's all going to be about ratios, so we can arbitrarily kind of choose those triangles that I've drawn, the ones that's highlighted there, to represent that. And if I look at this triangle, for example, that I've just drawn, this angle here is the one I'm interested in. It will be 60 degrees. So 120 degrees is a multiple of 60 degrees. It is something I can use here. So it'll always be that angle here inside that little triangle. I draw a ton of these when I work these problems out. Oops, that's not what I wanted. I draw lots of these triangles, these circles. Real quick and dirty, so I can actually visualize it and I can get my numbers right. A lot of scrap paper involved in this, okay? Now, what does that mean? Well, one thing you have to realize that in different quadrants of my graph, so this is quadrant 1, 2, 3, 4. In quadrant 1, the coordinates are always all positive. So my ratios, opposite over adjacent and all that stuff, will be all positive. But in quadrant number 2, my y values are always positive, but my x values are negative. So what's that going to do? Well, in this area, for example, the sine of 120 degrees is opposite over hypotenuse, so it's y over r. So it's positive over positive, radius always being positive. So it's going to give you a positive ratio, and it's going to be the same ratio. So the sine of 120 degrees is going to give you a positive number over r, the radius. So it's going to be the same as the sine of 60, which is root 3 over 2. And the cosine of 120 degrees, well, that'll be the adjacent over the hypotenuse. So again, if I look at my triangle, that's going to be 1 over 2. The problem is it's negative 1 over 2. And then tangent of 120 degrees is going to be y over x, so opposite over adjacent. So that will be, you get that one? Root 3 over 1. Except your 1 is negative. So this becomes negative root 3. So sometimes what turns out is the ratios stay the same, but sometimes they're positive and negative. So what does that all mean? It means that, and I'm trying to stay brief here, but it means that this little thing has a meaning all of a sudden. What is the meaning of this thing? It means this. In this quadrant, so I'm going to draw it up here again. In this quadrant, all the ratios are positive. But in the second quadrant, this one, only the sine ratio was positive. And in this one, it turns out the tan ratio is positive. And in this one, only the cosine ratio is positive. The other ones are negative. So CAST, like that, is just reminding me which ones are positive and which ones are negative. So any angle like that is going to be positive or negative. So I've kind of referred here to a couple of things. It's like, one is that when you're looking at angles, the trig ratios are based on triangles, but they kind of go beyond that. And that's something to remember. I'm going to add to your color nightmare. That the sinus of an angle is opposite over hypotenuse, but really it's, if you're thinking about on this unit circle, it's y over r. And the cosine is x over r. And the tangent, is equal to y over x, like that. So just think about which ones, in which quadrant is x and y positive or negative, okay? So that's kind of what we're talking about here. You have to know these fairly quickly. This takes practice. Happily though, it's actually very easy to practice. So there's a couple of things going on here. As a little example, for example, if I ask you what is the tangent of, let's say, 5 pi over, yes, I'm talking radians, 5 pi over 4, let's say. Okay, well that's and no calculator, not allowed to use calculator for this. Okay, we want exact values. How do you do that? Oh my goodness. Well, first I can convert this to degrees. By the way I do it, because I do think in degrees. The way I do it quickly though is I know that pi over 4 is 45. So anything that's over 4 is a multiple of 45. Anything over 3 is a multiple of 60 degrees, and anything over 6 is a multiple of 30 degrees, because pi over 6 is 30, pi over 3 is 60, so anything like that. So I can convert these fairly quickly because, for example, this right here, that yellow part, that's 45 degrees. So 5 times 45 degrees is 135. Is that right? I hope so. No, that is wrong. It's not. So 5 times 45 degrees is 235? That sounds better. Why did I do that? Well, if you're good at it, you don't need to, but it tells me which quadrant I'm in. And in this quadrant, is tangent positive or negative? It's positive. And tangent of 45 degrees is what? The tangent of 45 degrees is 1. So this will be, I don't need that. Will be 1 because it's also positive there. C-A-S-T, tangent is positive there. Another way to think about this, I'm going to just cram this full of writing here. This would be an absolute nightmare for you. Let's use another color. Is you can think of it this way. From 0 to 360. Right? From 0 to 360, sine is positive all the way to 180, then negative, then negative. So sine is positive in the first 2 quadrants. Cosine, that's 2, 3, 4 to 360. So it's positive in the first quadrant, negative in the second, negative in the third, positive in the fourth. And last but not least, tangent, which is an absolute nightmare. We haven't looked at the graph of this one, so I'll just draw it up just for your nightmares, right? It looks like, let's see if I remember it right. It's got an asymptote here, so it'll look like this. Like this, and then like this. You can graph it up on a graphing thing. So it's, the way it looks is, no, and I drew it wrong. I can remember that. Why am I? It's just too small a space to work in. 180, 360, there. Okay, so it is. I just want to draw it right. Is this right? Yeah, that looks right. It repeats like this on a 180 degree cycle or period. So it's positive, then negative, then positive, then negative. So it works like that. It's a weird little graph. I believe I shared with you a GeoGebra file that you can play with to look at that. So lots of information crammed in here. It takes practice. Don't worry, another video will be all about practice. Okay? I'll stop here. No, I skipped one thing. The 90-degree puzzle. So what am I going to do with that? I'm going to give myself some room. Get rid of my example. Okay, for 90 degrees, how do we do it? Well, if you follow this little recipe here, it allows you to think about what happens if it's 0 degrees, 90 degrees, 180 degrees, 270 degrees. Just think of your coordinates. This is, and let's make it on a unit circle. This would be 1, 0. This would be 0, 1. This would be negative 1, 0. And this one would be 0, negative 1. So if I think about that y over r being 1 in this case, the sine of 0 degrees, for example, would be 0 divided by 1. The cosine of 0 degrees would be 1 divided by 1. The tangent of 0 degrees, is equal to 0 divided by 1, so 0 again. Okay? The sine of 90 degrees, I'm not going to do these all of these, is y over r. So it'd be 1 over 1. The cosine of 90 degrees would be equal to 0. The tangent of 90 degrees is interesting because that would be 1 divided by 0, which is undefined. Not 0, not infinite, it's undefined. So with tangent, you can get undefined. And so on and so on. So for 180 degrees, the sine would be equal to 0, cosine would be equal to negative 1, tangent would be equal to 0. For 270 degrees, the sine would be equal to, because I'm just looking at the x and y, the sine would be equal to negative 1, the cosine would be equal to 0, and the tangent would be equal to undefined. And 360 degrees is the same as 0, and so on and so on and so on. So more to get used to. It's just a lot of memorization. Look at that sheet. It's a nightmare. You can find better, cleaner written versions of this online. Just have a look. Okay? That's part 2.